As the Riemann sums have so many little parts to it, different bits of knowledge you need to have, I've broken it down into 3 different videos with 2 introductory ones before we actually do the Riemann sums. So this one, upper and lower sums, what we're doing is we're finding the area under curves, approximating area under curves. So here we're going f of x equals 2 to the f from 0 to 3. There's our f of x equals 2 to the x. I'm going from x equals 0 to x equals 3. And it's the area under the curve down to the x-axis. So we can form rectangles, 3 rectangles, for example, on the left. So I'm going to go up from 0 where it cuts the curve. At 1, I'm going to go across until we get to 1. Then I'm going to go up from 1 up to 2 and across, and up from 2 to 4 and across. So there are 3 rectangles, all 3 with a base of 1 and a height of 1, 2, and 4. So our areas are those 3 areas, and they are 1 1s, 1 2s, 1 4s. Give you 7. Now that's an approximate area because we've lost those red sections. We've actually lost those. So, but at least we know that this is what we call the lower bound. It can't go below 7. Now we're going to do it by forming right sums. In other words, the same 3 rectangles, but touching on the right side. So they're not quite exactly the same. So instead of going from 0, I'm going to start at 1 and go back there. 2 and go back, and 3 and go back. So instead of having 1, 2, and 4, we now have 2, 4, and 8 as our y values. And this gives us 14. Once again, you'll see that we have gained areas now, extra areas. So this is too large for the actual area. But at least we have an upper and lower bound now. So we know that it's got to be between 7 and 14, the area under the curve. It is in fact approximately 10, 1, found using integral calculus. If we use 6 rectangles instead of 3, we'll increase the accuracy because we have far less lost area now or gained area there. So we could do left bound where it's f of 0, then f of half, then f of 1, then f of 1.5, etc. And the right bound where we start at f of half, and then f of 1, f of 1.5, etc. Sorry, I keep right clicking. What an idiot. Okay. And in fact, what we do now, have a look half times for each of them, and it's half times that height, which is, in fact, it's half times that height, yes, which is f of 0, there we go again, which is, all right, that's going to be 1, so it's half times 1, half times about 1.5, and so it goes on, we get 8,45. Doing the right sums, I don't start at 0, I start at half and go up and across, and there's a rectangle, there's another rectangle there, there's another rectangle there, ending with the one going up to here, the rectangles. And we end up with 11,95. Now that's better than 7 to 14. Now we have 8,45 to 11,95. So at least our upper and lower bounds are getting closer. Let's now go to a different graph. F of x equals 3 plus 2x minus x squared. Area bounded by the x-axis and the curve. So there's the curve, there's the x-axis, and obviously where it cuts, that's the start and the end of the area. So there's the area we have to find. If we do 8 partitions, we're going over a distance of 4, which means each partition's width will be a half. I'm getting myself all tongue-tied. So now, if we do left bounds, we're going to start at f minus 1, which will give you 0, and then f of a half. If we're doing right bounds, we'll start at f of a half minus a half, and then f of 0 going to f of 3, which is 0. So in fact, there are our left bounds and right bounds. Notice there's nothing here because f of 0 is 0. F of negative 1 is 0. F of negative a half goes up to there, so there's our rectangle. F of 0 is 3, if we substitute 3 into there, and so on. Our final rectangle will be f of 2.5. There we are. And of course, the other way around, this is fun because this rectangle comes from finding f of minus a half instead of f of minus 1. But we're going to end on f of 3, which is 0. So we're going to lose that bit of the area. So there we are, 10,5 and 10,5. Oh, they're both the same. Those will always be equal. For example, those I've lost, there I've lost it there and gained there, and here I've lost it there and gained there. They'll always be equal because of the symmetry of the parabola, and the areas will always be equal for the left and right bounds. So in fact, what I could do is find the left and right bounds and check it from there. 10,5. Even here, this is not symmetrical. This is a cubic graph, and in fact, it's steeper than it is there. So this is not. And we actually have the same area for 8 partitions. But if we go to 16 partitions, then we get 2,656. And if we go to 32 partitions, it's 2,664. So the more the partitions, the closer it gets. The actual area, correct to 3 decimal places, is in fact 2,664. So that was pretty good. What we lost, we've gained, mainly. Keep in mind that if the graph cuts the x-axis, areas above and below the x-axis are opposite in sign. This area here is negative and that area is positive. This is below the x-axis, so the y values are negative. So if I want to find the area enclosed, in other words, that and that, I have to say minus a to change its sign plus b, or the absolute value of each, but minus a because that's negative. Using a left sum, calculate the approximate area of the region described by the areas described. described. Use the partitions indicated, all right? So we got f of x squared equals x squared plus 2 between minus 5 and 3 there. Partitions minus 5, minus 4, minus 1, minus 2, minus 1, 0, 1. And there should be a 2 there too, sorry. You see there is a 2 there as well. There's our left sums there. And it'll be f of minus 5, f of minus 4, f of minus 3 for the heights of these rectangles. F of 2 will be the height of the last rectangle. And the widths are all going to be 1. So it starts at f of minus 5 for that height, and it ends at f of 2 for that height, for the left sums. And those all go to 77 square meters. So that's approximate, square units. That's approximate. If we use h of x equals 2 sine x, now have a look, we're using radians, pi by 4, and x equals pi, with a partition there. We cannot have it undefined, as in this would not be possible if it was 2 tan x, because tan is undefined at pi by 2, which is between the two. So, having a look at this. There is our sine graph, 2 sine x, amplitude 2, so it goes up to 2, 0 at pi by 2, pi, which is 180 degrees, and it'll be 0 at 0 if it was there. All right, like that. So we're going to form partitions, left sum as well. So there we are, there are left sums. Now we're going to substitute h of pi by 4, h of 3 pi by 8, h of pi by 2, etc. All multiplied by pi by 8, which is the width of the section. Give you 3,64 square units. Let's have a look at this one. F of x equals minus of x minus 1, x minus 5 between the x-axis, the y-axis, and x equals 5. There we are. So between the x-axis, the y-axis, and x equals 5. Partitions from 0 to 5. They're the partitions. Notice this one's negative, that's positive. They're the left sums. Notice this is a positive region, that's a negative region, so I must change the sign of this region. So there we have it. Change the sign of 0.5 times, and it's common, so I'll do that. F of 0 for that rectangle, and f of 0.5 for that rectangle. There we go, it's 0.5 times. Okay. F of 1 is actually 0 anyway. F of 1.5, f of 2, etc. You see it as we go up. And this gives us 14,125 square units. Once again, that is an approximation. That is below what it actually is, so we'll see that it's a lower bound. The Riemann sums takes us to find the exact area.